in the real time, if you want to propose any hypothesis, first of all, we are going to collect the data. We are going to collect the data. We collect the data in the form of records. And the record is nothing but an observation. Then what we will do? So once you collect the data, we are going to put all this data into a table. So if the data is present as a story, as a lines, it is very difficult to understand. If you put the same data in a table format, now it is easy to understand. Now, then later what we do the data analysis. In the last few classes, we have seen some kind of analysis. By doing the data analysis again, we are going to create a report, and we also submit this report in a form of a table. We have seen proper means table, proper frequency table, univariate tables and all. Now, so this table, if you see this table is much easier than this table to understand. And then once you are done with analysis, but sometimes for some people, even it is very difficult to understand. Now, at the end of the day, I am going to represent the data or the report by using a diagram. If I represent the data by using a diagram, it is going to be much easier to understand. Anybody can understand. It is easy to interpret the result. Say for example, take the SAS of that class. If I give the data set, if I ask you how many males and how many females are there by showing the SAS of that class, what you will do? You will count the females and you will count the males. Maybe it will take 1 minute or maybe 2 minutes. Or say for example, if I give the SAS of that cost data set, we have 428 observations, and I asked you in the cost data set, how many models belongs to sedan and how many models belongs to the sports and how many models belongs to say for example wagon or how many models belongs to SUV or the trucks. It will take 5 to 10 minutes to sort it out all the data manually, to put all the sedans into one category, all the sports into one category. It will take 5 to 10 minutes like. Okay, now we are a SAS programmer. By using a simple prop frequency procedure, prop frequency data set name, tables. Say for example, we have a what you call a make model or something, so a type. If I specify tables a type. So within half a minute, you are going to get how many sedans we have. Say for example, sedans we have 150 models. How many sports that we have? Sports say for example 230, and then how many wagons we have? How many trucks that we have? It is going to give all the information in a table format. Which one is easy to understand? This one or this one? Obviously, the right side, because we have the information in a table format, you can easily understand. But some people, even this is also difficult. Now what I'm going to do, whatever information that I have in this table, now I'm going to put all that information in a diagram. Say for example, these are the sedan cars, these are the say for example sports vehicles, and these are the say for example here SUVs, and these are the wagons, and these are the trucks, and these are the other vehicles. Now which one is easy for you? If I ask you which one is the more number, this one easy for you, or this one, or by seeing this one? Graph, a diagram. A diagram is easy to interpret, easy to understand. Anybody can understand. You don't need to have much knowledge, much skills. By seeing that diagram, you can easily understand. So that's why at the end of the day, whenever we have the data, we are going to collect the data, we are going to put the data in a table, and then we are going to do analysis, and then we are going to represent the analysis report in a form of a table so that everybody can understand that. Not only in the business world, in the banking world, in the clinical domain also, diagrams are so powerful. When we were kids, we used to learn, a diagram is worth of 1,000 words. అంటే మీరు 1000 words నుంచి రాసే స్టోరీని ఒక చిన్న డయాగ్రామ్ లో చెప్పేసేయచ్చు. Understand this one? So that's why we say a diagram is worth 1000 words అంటాం. అంటే మీరు 1000 words చెప్పడానికి ఒక స్టోరీని ఒక చిన్న డయాగ్రామ్ లో you can represent everything. So these diagrams are very powerful. And one of the SAS major advantage with SAS is it is a very powerful when it comes with the diagrams. It can give high resolution, wide variety of diagrams, particularly in the form of the graphs. Understand this one? So if you represent your data in a graphical manner, then it is easy to understand that one. And in SAS, we have so many topics, so many ways to get the graphs. But if you are taking the classes on only graphs, it is going to take 10 to 15 days only on graphs. But you do not require that much in-depth knowledge. What and all you require for to intermediate level, I'm going to explain next in 2 to 3 days time. Okay? And in general, if you see the graphs, generally graphs are 2 types. Okay? When you are in an intermediate and UC classes, okay, you used to write the graphs like this one. You used to take the 2 lines, and this we used to call as an x-axis, and this is called as a y-axis. On x-axis you will take 1 variable, on y-axis you are going to take 1 more variable, and where this x-axis and y-axis variables are going to get coincided, there we are going to connect that one with a dot symbol, and then later what we used to do, we used to connect the x-axis and y-axis variables are going to get coincided. There we are going to connect that one with the later, what we used to do, we used to, connect all these dot symbols, and then we used to plot a line like this one. This is one kind of. Understand this one? And there is a second kind. These are called in SAS, these are called plots. What you call that, right? Plot. Now we have a second method of thing. In this, what we are going to do, we are going to follow the second method. In this method, we are going to take, only one variable on x-axis. Now, by default, on the max, we are going to take a count or a frequency or maybe percentage. Now, say for example, take this as a third class. Here I'm going to get the x variable, and here I'm going to take that the frequency or a count, like 1, 2, 3, 4, like that one. Now, do you know how many females we have? We have 9 females. And how many males that we have? We have 10 males. Now, here I'm going to write this is a 9, and here we are going to have a 10. And this is called bar diagrams. And this we are going to get it through a procedure called chart. These are called charts. Major SAS graphs ఉంటాయండి, charts and plots. Okay. In today's class, I am going to explain about the charts. Okay. And then later we'll discuss about the plots. To get the charts in SAS, we have a procedure called proc G. To get the charts, we have a procedure called proc G chart. In today's class, we are going to discuss about the procedure called proc G chart. Proc G chart is useful to generate horizontal bars, vertical bar, pie charts, donut charts, star diagrams, and block charts. So, proc G chart is useful to generate horizontal bars, vertical bars, pie charts, donuts, star, and block diagrams. Okay. Now, whenever we want to generate a chart diagram, we are going to get a procedure called proc G chart. Okay. The data is equal to for which data set that we want to have this graphical diagram. I want to have it for SAS and dot class. What type of diagram we want to have? I want to have a horizontal bar. Now we should write a statement called h bar. And by the way, I want to have this horizontal bar for sex variable. I am writing the h bar, the variable name. Now keep a semicolon. Now write the run statement. Run is not enough here. We should also write the quit statement. In the moon, the quit statement, I could write on data. Okay. Now because that was a group, I told you we can write a change, exchange, append, repair, modify, save. We can write so many things in one procedure, and here also in one program we can write multiple things. So that's why run is not enough. We should write the quit statement. Okay. Now if I select the program, execute the program. Remember, now we have a diagram like this one. Can you see what the diagram that we have? We have a horizontal bar diagram because we have requested for h bar. H bar stands for horizontal bar. For which variable? Sex variable. Now this is how we have. And by default, can you see here, we have the frequency sex variable. In the sex, we have two types of values, F and M. Now F, what is it we are here? We have frequency. By default, now you know that females, how many students that we have? 9 students. And how many male students that we have? 10 students. And by the way, along with the graphical diagram, can you see what we are getting here? We are getting the statistics also. Frequency, cumulative frequency, percentage, cumulative percentage. Remember where we got this one in the previous classes? Proc frequency. And by the way, I want to have only this diagram. I do not want to have this statistics. Why should I require? I don't require the statistics. If I do not want to have those statistics, now we are going to write h bar 6 variable, and then what I'm going to do, I am going to specify, h bar 6 forward slash no stats. What is no stats option will do? It will suppress the printing of the statistics like this one. Now, I want to have this graph for each variable. Tell me what we are now. I'm going to specify proc with G chart. Data is equal to data set, which is a SAS help dot class. And then I'm writing h bar. This time, particular I want to have each variable. I do not want to have a stats. You can write the no stat, semicolon run, and then I'm going to write the quit statement. Now, this time, we are going to have an horizontal bar for which variable? We are going to have it for each variable. But do you know how many types of age values we have? Age groups? 600. We can have 11, 12, 13, 14, 15, and 16. But can you see how many bars I'm getting? Can you see what are the age midpoints we have? We have 11.4, 12.6, 6.0, 16. That means it is taking its own midpoints. That means it is not taking the original data. Okay, it is dividing all the 6 age groups into 5 midpoints. It is taking as a midpoint. But I do not want to have these, but I want to have original age data. Original is midpoint. So that means I want to have 11, 12, 13, 14, 15, and 16. If you want to have midpoints in that way, in the data how we have in that way, if you want to have, now we should write an option called discrete. What is the discrete option will do? Now the discrete option is going to take the discrete original values. Now can you see now how many parts we have now? 6 parts. Now can you tell me how many 11 year students that we have? 2. How many 12 years that we have? 5. 13, how many students we have? 3. And 14 and 15, how many students we have? 4. And 16 years we have only 1 student. So by default, by default, we are going to have a frequency combo. I'm writing proc G chart. Data is equal to SAS help dot class. I'm writing H bar. I'm writing, say for example, now name variable forward slash. I do not want to have any statistics, no stat. Tell me what is going to happen in this program. How many bars I'm going to get? I'm going to get 19 bars. Each name we are going to get as a 1 bar. And each name we have only one time. And we are getting the frequency 1. Understand this one? Now I'm writing proc G chart. Data is equal to SAS help dot class. But SAS help dot cost. I'm writing H bar. I'm writing, say for example, I'm writing, I do not want to have any statistics, so I'm writing no stats, run, and then I'm writing the quiz. Now select the program, equal the program, and this is how I build models, CSV, how many we have, sedans, sports, trucks, and vectors. It is going to show that like in the data set, each one, how many models that we have. Understand this a little bit? Now this time, I want to have my graph not in a horizontal bars. Okay, I want to have only horizontal bar only. I'm writing a program in this one. I'm writing proc G chart. Data is equal to data set name, which is SAS dot class. Then I'm writing, I want to have a horizontal bar, I'm writing H bar. I want to have it for age variable, and I do not want to have a statistics, no stats, and equal and run, and then I'm writing the query. When I execute this program, this is how we are going to get it. You get the age variable, but since I changed the age variable, I want to write it discrete because I want to have a original bars. Now we are going to get the original 6 bars. But I want to have these bars in 3D structure, 3D diagram. If you want to have a 3D structure, you know what we should write? Instead of H bar, you should write H bar 3D. If you specify H bar 3D, and this is how we are going to get it. And you see, we are getting the 3D bars. Previously, we used to get the 2D bars like this one, flat bars. Now we have the 3D bars. So to get it, we should write the H bar 3D. Now I want to have vertical bars, not horizontal. I want to have a vertical manner. If you want to have a vertical manner, now what is the statement we are going to write now? We are going to write the V bar. By the way, I am writing proc G chart. Data is equal to my data set name, which is SAS dot class, and then I am writing a statement called V bar. And I want to have this vertical bar for age variable, so sex variable, and I am writing the sex, and then I am writing the run statement, then I am writing the quit statement. Now if I select the program, execute the program, now can you see we are getting the vertical bar? Can you see there is a difference between horizontal and vertical bar? When I request for a horizontal bar, along with the bar we used to get statistics. But can you see there are no statistics now? For vertical bar, you will not get any statistics.
Sir, ఇక్కడ discrete అనేది numerical variables కి యూస్ చేసుకుంటాం సార్.
Discrete required for character variables.
Okay sir.
Because character variables ఎన్ని values అన్ని పాస్ వచ్చేస్తాయి, ఎన్ని రూల్స్ ఉంటాయి.
Okay sir.
Now, I'm writing proc G chart. Data is equal to SAS help dot class, and then I'm writing this time V bar 3D. Now I want to have 3D structure for sex variable. I'm writing vertical bar 3D. So we can request for 3D structure for even vertical bars also, and this is how we are going to get what happened. Why it is so slow? Now, this is how we are going to have. We have a 3D structure, we have for the sex variable. And we can understand female by default, we have a 9. By default, we are getting the frequency and 9, and we have a male 10. Now, I want to get it for the age variable. Now, I'm writing a plot G chart. Data is equal to self-class. Now, I want to have vertical bar 3D. I'm writing B bar 3D. I want to have it for age variable. Now, I'm writing a run, and then I'm writing the picture. So, age is a numerical variable. Now, tell me how many bars I'm going to get now. I'm going to get only 5 bars. Because by default, what it will do? It is going to take 2 points. But if you want to have original data, what we should do? What we should do? You should write discrete. Now, I'm writing a discrete option. Now, we are going to have a discrete value. Can you see how many bars that we have now? 6 bars. So, that means it is taking the original data. Original bars. Okay, but I do not want to have in this way. I want to have in my own way. I want to have 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we do not have a data for 10 is 10, 17, 18, 19, 20, but I want to show that one in my graph. If you want to have your own midpoints, now we know what we should do. Instead of writing the discrete, we are going to specify an option called midpoints is equal to. A midpoint is equal to. I want to have midpoints from 10 to 20 by 1. And if you have midpoints outside, is 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. But do we have a data for that one?
No.
Midpoints is equal to I'm writing midpoints is equal to select the program. Can you see? Now we have the midpoint 7 on